Hi, welcome. I am Philos, and today I'll be taking you through how to perform independent samples t-test using SPSS. So, without wasting much time, let's start. Now, I'm looking at a particular community in Ghana where the two major works people do in that particular community, Galamsey and farming. But here lies the case that a lot of people are going into Galamsey more than the farming. So, I decided to collect the average weekly income of 25 people who are into Galamsey in that community, and also 25 people who are into farming in that community. So when I scroll down, you see farming at the down, farmer. Okay, then you see their income at the front of each. Okay, and the top I have Galamsey, each person's average weekly income. Okay, then farmer to average weekly income throughout. So I have 25 sample of farmers and 25 sample of Galamseyers. Galamsey means illegal mining. Okay, now let's go to the variable view. Let me show you something. At the variable view, so let's come to values. Now when you click on the values, you realize I've assigned the number 1 to Galamseyers and 2 for farmers. Okay, so that's what I want you to take note of over here. Now let's go back to the data view. Now at the data view, when I click on value labels at the top here, you see that all the ones that are Galamsey will change to 1 and farmers will change to 2. But our main interest is to compare the average weekly income of Galamseyers and farmers. So to do that, first you click on analyze at the top here. So when you click on analyze, then you go to compare means. Now when you get to the compare means, don't click. Okay, come to the right and then move to independent samples t-test. Then you click on it. Then the independent sample t-test dialog box displays. Now the exact thing we are comparing is their average income per week. Okay, so since we are comparing their average income per week, we'll move it to the test variable box. Okay, now the average income per week, we are comparing it for two different occupations, that is Galamsey and farming, isn't it? So we click on your occupation and then move it to grouping variable box by clicking the arrow here. So when you click that, you see that there are some 2 question marks here. So the next thing you do is to click on define groups. Now when you click on define groups, now group 1, you made Galamsey 1, isn't it? So you can enter 1 at the front of group 1 and then you enter 2 at the front of group 2. This means that the first group is group of Galamseyers and the second group is group of farmers. Okay, then you click on continue. Then you come to where they've written options here. Okay, then you click on it and then check the confidence interval percentage. Now the default confidence interval percentage is 95%. Okay, and you know 95% confidence means 5% level of significance. If it's 99, it is 1% level of significance. Okay, but I'm using 95. You just have to come and confirm it. Okay, but I'm using 95, so I just continue. Then after doing all that, then you click on OK. Then instantly SPSS will bring out this output. Now you see that we have 2 tables here. The first table is group statistics, which is a descriptive statistics, and then the second table is independent samples test. Now let's look at the first table. Now when you look at the first table, you'll see they've written Galamsey here and I have N here. It means that I collected 25 sample of Galamseyers and also 25 sample of farmers. And then the mean weekly income of all the 25 sample of Galamseyers is 685.64 Ghana cedis. And then the mean weekly income of the 25 sample of farmers is 551.36. And these are their standard deviations and these are their standard errors. Now it is clear from this descriptive statistics that the mean weekly income of the Galamseyers is more than mean weekly income of farmers. But what we are interested in this video is the inferential statistic, the hypothesis test. We want to know whether the mean income of Galamseyers and farmers are statistically significantly different or not. So for that matter, I'm going to set the hypothesis. Now the null hypothesis is that the two means are not statistically significantly different. And then the alternate hypothesis is that the two means are statistically significantly different. Now when we come to the independent samples test table, the table has been divided into two parts. The first one is Levin's test for equality of variances, and the second part is t-test for equality of means. Now, before you can use the t-test for equality of means, we need to check the equality of variances first. Now, to do that, we are going to look at the p-value of the equality of variances. Now, where they've written SIG here, SIG, that's the p-value, okay? And our confidence was 95%, which means 5% level of significance. And 5% in decimal gives you 0.05, isn't it? So, our level of significance is 0.05. Now, the rule is that if the p-value is less than the level of significance, which is 0.05, then equal variances are not assumed. But if the p-value is greater than the level of significance, which is 0.05, then equal variances are assumed. So when we look at this particular p-value, this particular p-value is 0.029. And this 0.029 is less than the level of significance, which is 0.05. So we will say equal variances are not assumed. Now, when we come to the t-test for equality of means, now when you look at the computed t here, you will see that two different computed t's have been provided. When you also look at the degrees of freedom, you see that they provided two different degrees of freedom. When you also look at the p-values, you see that they provided two different p-values going, okay? But here you can't choose the two of them, you have to use one. The choice of the one you use among them depends on your conclusion for equality of variances. Now, we concluded that equal variances are not assumed, isn't it? So because we concluded that equal variances are not assumed, we are going to use the results at the down. If you conclude that equal variances are assumed, you use the results at the top. That is why when you look at this part, you see that they've written here that equal variances assumed, and at the down they've written equal variances not assumed. So because we concluded that equal variances are not assumed, we are using the results at the down here, okay? Now, to arrive at our final decision on whether to reject or not to reject the null hypothesis, I'm going to show you three different methods of doing that, okay? So the first method is to use the critical value method. The rule is that if the test statistic, which is this t here, is greater than the critical value of t, we should reject the null hypothesis. But if the test statistic, this t, is less than the critical value of t, then we do not reject the null hypothesis. So let's look for the critical value of t and check if we should reject the null hypothesis or not. Now, what is the degrees of freedom? The degrees of freedom is 42.854. So let's approximate it to 43. So let's go to the t table and then look for the critical value of t. Now, this is the t table, and our level of significance is 5%. So we check it out where they've written two tables. Then we trace it down to degrees of freedom of 43. So let me scroll down to 43. But in my table, I do not have degrees of freedom of 43. I only have 42 and 44. So I know 43 is between 42 and 44. So for that matter, I'll take their t-scores. So when I look at the t-score of 42, it is 2.018. And then that of 44 is 2.015. So I can add the two t-scores together and divide it by 2. When I add the two t-scores and divide by 2, I'll get 2.0165. So the 2.0165 is the critical value of t. So let's go back to SPSS. So we've gotten the critical value of t to be 2.0165, isn't it? Now let's compare the test statistic, which is 4.771, and the critical value of t. We can see that the test statistic of 4.771 is greater than the critical value of t, which is 2.0165. That the decision is to reject the null hypothesis. So since we've rejected the null hypothesis, it means we are saying that the means are statistically significantly different. Okay. Now let's look at the second method. The second method is the p-value method. And this is the p-value for the t-test, where they've written SIG2 table. Here too, the rule is that if the p-value is less than or equal to the level of significance, which is 0.05, we should reject the null hypothesis. But if the p-value is greater than the level of significance of 0.05, we should not reject the null hypothesis. But when we look at our p-value, please remember we are using the results at the down to interpret, okay? Since equal variances are not assumed. Now when you look at the p-value at the down here, it is 0.000. 0.000 is less than 0.05. Since 0.000 is less than the significance of 0.05, then we reject the null hypothesis. So you see that we've ended up making the same decision we made using the first method. So the decision is to reject the null hypothesis. So since we've rejected the null hypothesis, it means that the two means are statistically significantly different. Okay. Now, the third method is using the 95% confidence interval of the difference. Now, to use it, the rule is that if the lower and the upper have the same sign, you should reject the null hypothesis. But if they have different sign, you do not reject the null hypothesis. When you look at the lower and the upper, they are both positive, which means they have the same sign. So we reject the null hypothesis. So since we are rejecting the null hypothesis, it means we are saying the means are statistically significantly different. So generally, what that means is that the mean income of Galamseyers is statistically significantly different from the mean income of farmers, or the mean income of Galamseyers is statistically significantly more than the mean income of farmers. So you can use this to explain why people go into Galamsey more than farming. And it is clear from our statistics here that it is because of higher income. That's why people are going into Galamsey more than farming. You can recommend to the government various ways by which we can increase the income of farmers so that people will be motivated to go into farming and demotivated from going into Galamsey and stop polluting the environment. Okay. And for those who have not watched our previous videos on SPSS, you can check the description below or check our playlist for SPSS. Do well to subscribe to the channel so that you can see more videos on SPSS, Stata, Excel, R, SAS, Python and other softwares. Thank you.